Hello, this is Peter from Educomondo and a warm welcome to our STEAM project number 18, in which we will build a car speed dial. These lessons are for the absolute beginning STEAM teacher. No prior knowledge of programming or electronics is required. We call this level the Explorer level. The goal of today is to control the needle of a car speed dial by using a new type of motor, the servo motor. We will use a special library for this servo motor called servo.h. We will also introduce a special type of resistor, namely the potentiometer. We will talk about Ohm's law, and the most important, we will have our class work as a team. Let's take a closer look at the servo motor. This motor consists of three main parts. There is the small electric motor, a gearbox, and an output arm or disc. It is most often used in situations where a precise positioning is required. For instance, to turn an axle on a remote car, adjust the flaps of a remote control airplane, or control the movements of a robotic arm. The standard servo is very precise to position the axis between 0 and 180 degrees, although you can also find other servos going up to almost 360 degrees. The motor is connected to the Arduino by means of three wires: the positive and a ground wire and a data wire. Because the motors that are included in the starter kits are quite small, they don't consume a lot of power. We don't need a controller, and we can connect them directly to the Arduino or the breadboard. The other component that we introduced today is the potentiometer or pot meter. These come in many shapes and formats. The one that is in the kit we are using is this small blue one. It is a 3-pin variable resistor of which the outer terminals are connected to 5 volts and the ground. From the middle terminal we will read its values from an analog pin used as input. Before we dive into the project, we will talk about a very important equation in electricity, Ohm's law. Let us draw a simple circuit with a power source of 5 volts, one resistor and one red LED. In our previous lessons, we used an LED and we took a resistor of 220 ohm. But how did we know what that value should be? Ohm's law states that the voltage is equal to the current multiplied by the value of the resistor. There is an easy way to remember Ohm's law by drawing the Ohm's law triangle. So let's draw this triangle, and the way to read it is quite simple. Voltage equals ampere multiplied by the resistor value. The current, expressed in ampere, equals to the voltage divided by the resistor value. And the resistor value equals to the voltage divided by the ampere, the current. From the datasheet, we know that the red LED consumes around 23 milliampere. Since we are using 5 volts, Ohm's law states that 5 volts divided by 23 milliampere equals 217 ohms. That number is very close to the 220 ohm that we used. What if we have two resistors in series, so one behind the other? The total value is the sum of the resistor 1 and 2. Assume we have a resistor of 500 ohm and one of 300 ohm, the total will be 800 ohm. Let's conduct some small experiments with the potmeter. First, we will measure with the multimeter the total value by connecting one of the outer terminals with the middle one. And as you can see, the value is 10k ohm or 10,000 ohm. Let us now connect a second multimeter to the other terminal in the middle. On the two screens, you are able to see the changing values as we are turning the knob of the potentiometer. You can draw on the whiteboard this schematic to explain the working of the potentiometer. The two terminals are connected via an arch. This arch has a certain resistance value. In our case, that was 10,000 ohm. The middle terminal is connected to what is called a wiper. This wiper is connected to the knob so that it can be turned to different places on the arch. Each position will correspond to a different ohm value. In essence, you can compare this with two different resistors in series. Now that your students understand the working of the servo and the potentiometer, let's hand out the components for the project. We have the microcontroller and the breadboard, the servo motor, the potentiometer, six jumper cables, a couple of preformed wires, the cardboard figure of the dial, and we made a special red colored needle to make sure that the movement is clearly noticeable. And we're also going to use some sticky stuff like double-sided tape or these buds. Your class is ready to build the project. It is not complicated, so allow some time for your teams to try the project by themselves. As always, encourage teamwork. Because the potmeter and the servo will need 5-volt connections, we start by connecting the breadboard outer rails to the 5-volt and the ground of the microcontroller. Next, we mount the potmeter on the breadboard. The outer legs are connected with a preformed wire to the positive and the negative rail of the breadboard. The middle leg is connected to the analog pin A0. Now we can connect the servo. The brown and red wires are the ground and the 5 volt, so we connect those to the outer rail of the breadboard. The orange wire is the control wire, and we connect that wire, for instance, to our digital pin number 8. Of course, the most important is to add the needle and the cardboard dial. We use something that can hold the servo on its place. Now, one piece of advice: do not use these sticky things on the breadboard, as they will make a mess and clog the holes of the breadboard. Let's open up an Arduino sketch and start programming. Once again, your students are now at a proficiency that they should be able to start writing the program themselves. Let them shout out to you which functions and commands will be needed. We start by putting the name and the variables at the top of our sketch. Lesson 18, Speed Dial, Variables and Declarations. The first thing we need to know is that we will work with a library. This library is called servo.h. We will call up the library by using the hashtag include and then in between the pointed brackets servo.h. From that library, we have to create an object. We give the object any name we like, and for our lesson we will call it myServo. And we use the command servo myServo. Because we connected the servo to pin 8, we will give it also a name. So integer servo pin equals 8. The servo will have to show us different degrees between 0 and 180, so we need a variable to reflect those degrees. int servo degrees, and we shorten this into servo degr. We connected the middle pin of the potentiometer to pin A0, so we are going to give it also a name integer pot pin equals A0. And we will also need another variable because we will be reading out of that potentiometer, and we will call that variable the pot val. Let's go to the setup function. From the library, we need to attach myServo to the servo pin using the command myservo.attach. We will check the working of the potmeter by checking the values on the serial monitor. So we need to start the serial monitor with the serial.begin and in between brackets the 9600 baud rate command. And lastly, we have to define pin A0 as an input pin because it is the pin that reads from the potentiometer. So it's a pin mode A0 as an input. Now it's time to go to the function loop. The first thing we want to check is whether the potentiometer is working properly. And we do that by first creating that the pot val equals the analog read of the pot pin. And then we're going to type very quickly a serial print command, which will show the pot value on our serial monitor. And we're also going to introduce a delay of about 1 second, because otherwise the values will just be shown too quickly. Let's open the monitor, and while turning the knob on the potmeter, let your students take note of the values. Remember that we should get values between 0 and 1023. But what do we experience in reality? We notice that the values are actually between, something around 80 and around 1000 on average. We don't really get these nice clean minimum of 0 and a maximum of 1023. This is quite normal, and it is related to the accuracy of the components. Because we still need a maximum of 180 degrees and a minimum of 0 degrees, we will make use of an Arduino function called map. The variable servo degrees will be defined by reading the pot val, but we map the minimum of 80 and the maximum of 1000 to 0 degrees and 180 degrees. That way we will achieve a nice full arch even without reaching the theoretical values. So we write servo degrees equals map, and in between rounded brackets we first say it is the pot val, which we read from the pin. Then we say first the two values that we have seen, 80 and 1000, and we map that to the 0 and the 180 degrees. Now we can send that value to myServo using the myServo.write servo degree command. That's it. Turn the knob and the servo will show different angles, just like a car speed dial. If it doesn't work, no panic. Let your students do logical fault finding as in the past. Were there any error messages on the Arduino IDE? Are there no loose wires or connections on the breadboard? Did they check all components? Is there a proper USB connection between the computer and the microcontroller? And so on. Let's revisit the goals of today's lesson. First of all, we controlled the needle of a car speed dial by using a new type of motor, the servo motor. We applied a special library for this servo motor called servo.h. We included a potentiometer, and now we know how it functions. And we had our first encounter with Ohm's law. But the most important, our class worked as a team, did some critical thinking, and has been successful. I hope that you and your class had some great fun with this project. Time to wrap up with some assignment ideas. First of all, the servo motor is very versatile, so why not think about a small project where this servo opens the lid of a waste basket. How would you do that? How would you connect the servo to the lid? The second assignment is about some math. We use the function map, but what does this exactly do? Ask your students to come prepared for the next lesson to explain the math behind this function map by using an XY graph and calculate the slope of a line. Again, these are just some suggestions. As a teacher, you know your class best and you are ideally placed to come up with your own assignments. This concludes our Project 18, the car speed dial. Controlling motors is an important skill for robotics. In our next lesson, we will work with yet another kind of motor called the stepper motor. I am looking forward to welcome you again in lesson number 19 called the clock rotations. Take care and bye-bye for now.